This time with Relational AI, we're going to allocate compute to AI labs in our data center. We need to prioritize, schedule, and assign AI workloads, taking into account power, margin, and concentration to come up with a defensible plan. Beyond using LLMs themselves to do the analysis, we need to layer on reasoning. So we'll start with descriptive queries to understand the ontology in the current situation. We're going to do predictions on the workload usage, rules for eligibility and priority, graph for dependencies and impact, and finally, prescriptive optimization to pick the assignments across a number of different scenarios. We start with data representing our data center, so understanding the workloads, compute, and demand. Next, we need to build an ontology on top of this data. We now have an ontology representing the structure and can start to build reasoning on top of it. But first, let's understand the current situation. How is demand distributed and who dominates it? Okay, we can see the drivers of demand, and that tuition is the main factor. Now time for a prediction. Which workloads will run hot next? We build our graph neural network, and thanks to its structure, can see the highest predicted utilization. Next, the rules analysis. Which workload pool pairs are eligible, which can help inform our optimization. And now that we've prioritized workloads, do a graph analysis on impacts and dependencies. So graph results, let's figure out the implications. This helps us understand the dependencies between workloads and which will be blocked. Now we'll pass all these analyses into an optimization problem. We are prioritizing and assigning workloads, classifying the assignments. Each workload must be assigned at most per scenario. We need to take into account GPU compute availability. We're constrained by power availability, our own operating margins, and a concentration cap to manage risk. Our objective takes into account priority requirements, utilization probability, strategic value. We ran 24 different scenarios, reflecting different combinations of power, margin, and diversity constraints. This allowed us to explore potential outcomes and see which constraints were binding, and ultimately navigate trade-offs across revenue, margins, and concentration risk. So how should this inform our decision? Our recommendation is full power envelope, unconstrained margin, and no diversity cap, because it gives us a balance without sacrificing revenue. If we're willing to accept concentration, we have our solution, and we want to integrate it back into the ontology so other people can use it. That means just adding a new concept for allocation plan with the properties from the solution and indexing by scenario. We had a complex decision to make. We chained together descriptive, predictive, rules, graph, and prescriptive reasoning, building on our ontology, and ultimately extending it with the reasoning for compute workload assignments. So if you're interested, check out Relational AI. Got skills you can use in your coding agent and templates to follow to adapt to solve your own problems.